As you're probably well aware, our DNA is like this humongous blueprint of information on how to make a human. Usually, this massive document is packaged up nicely into a storage bin called a chromosome. Actually, usually we have 46 chromosomes that we use to neatly organize all our information, depending on how you define organize. Each of the 46 chromosomes is actually part of a pair of chromosomes, since you get one from each parent, so 23 pairs. If you wanted to make another human, first you'd have to find someone that feels the same way, and then you both contribute half your chromosomes, so one from each pair, right? 50-50. Now, what if someone contributes one too many? Say dad contributes 23 and mom contributes 24. Is that possible? Yes, and it's the basis of one of the most common chromosomal disorders, Down syndrome. Someone with Down syndrome has 47 chromosomes instead of 46. Specifically, they have an extra copy of chromosome 21. So instead of 2, they have 3. So Down syndrome is also known as trisomy 21. In other words, 3 chromosome 21s. Alright, so in order to package up half the chromosomes into either a sperm cell or an egg cell, you actually start with a single cell that has 46 chromosomes. Let's just say that we're making an egg cell for the mother. I'm just going to show one pair of chromosomes, but remember that all 23 pairs do this. So the process of meiosis starts, which is what produces our sex cells, and the chromosomes replicate, and so now they're sort of shaped like an X. Even though that there are 2 copies of DNA here, we still say that it's one chromosome, since they're hooked together in the middle by this thing called a centromere. Okay, now the cell splits in 2 and pulls apart the paired chromosomes. So in each of these cells, you've now got 23 chromosomes. Now the 2 copies of the chromosomes get pulled apart, and the cell splits again, which means 4 cells, each still with 23 chromosomes. Now these are ready to pair up with a sperm cell from dad that has 23 chromosomes as well, totaling to 46 chromosomes, and voila, 9 months down the road, you've got yourself a baby. Now, with Down syndrome, or trisomy 21, a process called non-disjunction accounts for about 95% of cases. Non-disjunction means the chromosomes don't split apart. If the chromosomes in this first step don't split apart, then one cell ends up with both chromosomes and the other gets none. Then the final result is 2 cells with an extra chromosome and 2 cells missing a chromosome. Non-disjunction can also happen in the second step though. So first step goes great, and both cells have a chromosome. But if they don't split apart in the second step, then the final result is 1 cell with an extra chromosome, 1 cell missing a chromosome, and 2 with the right number of chromosomes. Now if a sperm cell combines with any of these that have a duplicate of chromosome 21, then the combined cell will have 1 extra copy of chromosome 21. In other words, 3 chromosome 21s, or trisomy 21. In case you were wondering, the sperm could also combine with these cells that have a missing chromosome. If that's the case, then there would be a total of only 1 chromosome 21, and we would call that monosomy 21. In my example, we followed the egg cell from the mother, but this process could happen the opposite way, where the sperm starts out with too many or too few copies of chromosome 21. Apart from non-disjunction, Robertsonian translocation accounts for about 4% of trisomy 21 cases. Translocation, in this case, is a fancy way of saying move from one place to another. So a part of one chromosome moves and switches places with a part from another chromosome. In this case, the long arm of chromosome 21 translocates over to chromosome 14, and you end up with 2 hybrids, one with both long arms and one with both short arms. This little guy with the short arms carries just a little bit of usually non-essential genetic information, and is typically lost by the end of meiosis. So there are a few ways that this can go down. First, including the translocated chromosomes, they replicate, and now these could split into one with both normal chromosomes and one with the long guy and the short guy. In which case, after splitting again, you'd have 2 normal cells and 2 cells with a big guy, since remember we lost the little guy along the way. So now contribute the other parent's DNA, and you've got 2 normal cases, and then these 2 cases are called balanced carriers. And we say that it's balanced because you've still got both long arms, and so most of the genes are still here. Kind of like a 2-for-1 deal. Okay, now let's say that the normal chromosome 14 ends up with the short, and normal chromosome 21 with the long. Now you get 2 cells with the normal and long arm, and 2 cells with the normal and short arm, which remember is usually lost. So these have 1 extra chromosome 21, since the long arms carry most of the genetic material for both chromosomes 14 and 21, and these ones are missing chromosomes. Now combine these with the other parents again, and you have trisomy 21 here and monosomy 21 here, since it's missing a chromosome 21. If this process was switched such that chromosome 14 ended up with the long chromosome first, then you'd ultimately end up with trisomy 14 and monosomy 14. So of the 12 possibilities, 2 end up being trisomy 21, right? With Robertsonian translocation, one of these chromosomes needs to be chromosome 21, right? Even though the other is usually chromosome 14, it can actually be other chromosomes as well, like chromosome 22. Finally, about 1% of patients are mosaic, meaning that their cells are mixed, and some have 46 chromosomes and some have 47. How does that happen though? Well, let's think about what happens after conception. So you've got this one cell called the zygote that needs to develop into a human, right? Since we aren't single-celled organisms, it has to divide over and over again, essentially producing every kind of cell in the body. Now, each of these divisions is called mitosis. Non-disjunction of chromosome 21 can also happen during mitosis, in which case you'd end up with one cell that has an extra chromosome 21, and one without. So one with 47 total chromosomes and one with 45. The cell with 45 chromosomes isn't able to survive, but the one with 47 does survive, and continues to replicate and produce more cells with 47 chromosomes. If this happens early on in development, then you can imagine that a lot of cells down the line can have 47 chromosomes, right? If it happens later on, then less cells will have 47 chromosomes. Mosaics can also happen when the zygote starts with trisomy 21, or 47 total chromosomes. In this case, non-disjunction would produce one cell with another extra chromosome 21. So this one has 4 chromosome 21s, totaling to 48 chromosomes. And this cell can't survive. The other cell, though, loses one of its 3 chromosome 21s. So now it only has 46 chromosomes, which happens to be the normal amount of chromosomes, right? And this is sort of like the opposite situation, because now, through a mistake, you've actually ended up with the right amount of chromosomes. So if it happens early on in development, you'll actually end up with more cells with the normal amount of chromosomes. If it's late in development, though, then less cells will have the normal 46 chromosomes. Having an extra chromosome 21 is one of the most common chromosomal disorders, and not surprisingly, it has an effect on almost every organ system in the body. And for that reason, there's a long list of common issues for those affected with Down syndrome. Here are some of the major ones: septal defects in the heart's chambers, usually between the 2 atria, duodenal atresia, increased risk of acute lymphoblastic leukemia, mental retardation and an increased risk of Alzheimer's, and sterility in males. There are several physical characteristics as well, like a simian crease in the hands, a gap between the first 2 toes, a flat facial profile, and epicanthal folds. Having an extra chromosome 21 is thought to affect these systems by an overexpression of genes on chromosome 21, since there's an extra copy contributing to gene expression, which changes the development of all the systems just listed. Now, a major risk factor for Down syndrome is maternal age, the age of the mother. Trisomy 21 happens about once in 1,500 births where the mother is younger than 20 years old, contrasted to about 1 in 25 births when the mother is older than 45 years old. During pregnancy, some screening tests can be done, and certain markers suggest higher risk that a baby might have Down syndrome. Alpha-fetoprotein, or AFP, unconjugated estriol, or UE3, are on average lower when compared to unaffected pregnancies, and human chorionic gonadotropin, or HCG, as well as inhibin A are both typically elevated compared to unaffected pregnancies. An imaging test using ultrasound can also be performed, where clinicians look for nuchal translucency. None of these are exact indicators of Down syndrome, however, but they do give valuable information about the overall risk of Down syndrome. Even though there's a long list of complications and hardships for people with Down syndrome, improved medical care has led to a much greater longevity and quality of life. Many individuals with Down syndrome are able to thrive and lead full lives. Thanks for watching. You can help support us by donating on Patreon or subscribing to our channel or telling your friends about us on social media.